As I was introduced, my name is Oliver. I'm from a company called Buoyant. We're a small startup also around the corner above Kate O'Brien's. So if you're at the bar, come say hi. And I'm here to talk about magic security sprinkles. But first, a little bit about me. I worked at Yahoo for a few years in production operations, and then most recently, well, before Buoyant, was at Twitter from about 2010 to 2015. Quick show of hands, who was on Twitter in 2010? Was it up? No, it wasn't. It was down all the time. That's why I wanted to go work there. And I got to work on some really fun projects. One of which was observability. So I worked on the kind of telemetry system that they use today to monitor every production service. Zipkin, you may have heard of, is an open source tracing project that came out of that. And then I moved on to the traffic team. And I'll be talking more about the traffic stuff today than the observability stuff. Twitter in that time wrote a networking library, Finagle, which is kind of at the heart of what I'm talking about today. Been really involved in that project. And we've been really involved in Kubernetes, or not development-wise, but participating-wise. It's been a great project to watch over the last couple of years. All right, so we're going to talk about microservices. We'll talk about a proxy we built called LinkerD. And hopefully the live demo gods will favor me, and we'll be able to do a little bit of a demo for that. All right, so microservices. Who here has heard the word microservices before? Oh, come on. All right, who here wants to tell me what a microservice is? No? No, what's a microservice?
A very small service.
A very tiny service, yes, good answer. That's the most common answer, yeah. And what we get from there is that it's usually small in scope, not necessarily small in size, memory-wise, or CPU-wise, but very fixed scope, and frequently very kind of team-oriented too, where one team operates it in a company. Who here is doing microservices today? Great. Why are you doing microservices? OK, well, maybe you don't know, but we'll talk about that. So generally, the reason Twitter at least pursued microservices is because we had to scale the team, and we had to scale the system. We had a huge Ruby monolith, affectionately known as the monorail. And there was one team that had to do all the deploys. And if that deploy went poorly, that team's day went very poorly, as did everyone else who wanted to deploy that day. And so this is around 2010, when the site was down all the time. We said, OK, well, we've got to break this up. We need to work on more features. We need these features to be able to move quickly so that when people deploy, they own that. And if it's down, they own that. And so this is really an organizational hack. The reason we go to microservices is for flexibility at the organization level. It's not some magical sprinkles. What you don't get is any of this stuff. Any of the stuff we care about as operators kind of really falls down once you go into the microservice world. The tools we're used to debug that monolith, to S-trace it, to look at logs, all of these things start to break down when we decompose. And so despite the title of my talk, the sprinkles are a lie. There are no magical sprinkles. I'm sorry. What we have to do is we have to build new tools that start to compensate for the deficiencies we've introduced by going after flexibility at the organizational level. And in microservices, this means communication. So where we used to have function calls and libraries, now we're talking about network calls. We're talking about gRPC. We're talking about network dependencies. And when we're talking about networks, we're talking about failure. And so I care about both resilience in terms of the site's up. If the site's not up, it's not very good. And also security, that it has to be safe and predictable, and that we can understand how these things work. And so because we're talking about communication, it's helpful to think about this in terms of the OSI model. Hopefully this stack here looks vaguely familiar. Maybe you haven't really thought about some of the layers before and what they mean. But this is kind of my view of the world and what we're trying to build at Buoyant. And so down at the bottom of the stack, we have the data centers that hopefully you're not ever in, right? These are AWS or Google, right? They're sponsoring. Azure or some colo. You're not in a data center racking hardware, I hope. And you probably have a network operator team that maybe your company employs, but maybe it's just Google that's doing all of the BGP and whatnot. Obviously, there's products around that. And at the end of the day, we have some orchestration layer, like Kubernetes or Mesos or one of these things. And their job is to get a process running, listening on a socket, ready to serve requests. And so we can think about this in security terms. We have CoreOS's security stack with TPM down at the bottom, giving us hardware security, up to, and through Rocket and Kubernetes, giving that process kind of some provenance. And then when we go into the network side of things, we have IPsec and IP tables, which are well-known tools for the old world of securing systems. And these things operate down here at layer 3 and layer 4. And TLS, obviously, is this ubiquitous security sprinkle that we just deploy everywhere, and it works. And then up at the top, we have our application, right? And this is the kind of service that you're writing. And hopefully, this thing isn't really aware of whether it's on Kubernetes or etcd or any of these things. And so we want this kind of very opinionated infrastructure that works and very opinionated application layer that works. And these things shouldn't really be too tightly coupled. I want to be able to move these things around. I want to run them on my laptop, maybe without Kubernetes. And this should all just work. And in this unknown middle layer, who here talks about layer 5 or layer 6 ever? Right? Nobody. So this is really what we think of, especially in the gRPC talk we just saw. This is what we're talking about. We're talking about the mapping of all of these business concerns at the top onto some connection somewhere in some serialized format. So layer 6 gives us a serialization layer, and layer 5 gives us multiplexing, all sorts of problems we want to solve there. Usually this talk I do is much more focused around the reliability aspects we can solve at layer 5 in terms of load balancing, retries, that sort of thing. And here I'm going to talk a little bit more about the security aspects. Brief aside, hopefully you've seen this all this morning. Kubernetes, the main advantage it gives us, the most novel thing in my mind, is the pod concept. Hopefully this isn't rocket science. You've heard this before today. So pods give us the ability to run separate groups, applications on the same host. And these pods can be composed of multiple containers, and they share an IP. So they can talk to each other of a local host, and everything just works. There are other ways of doing this in other systems, but Kubernetes really got this right from the start. With that, we also get services. So we have a built-in service discovery mechanism. I can create objects in Kubernetes that map over pods. I can say, I want a service, and that service is composed of all pods with the label app as A. And this is great. We don't have to deal with Zookeeper or etcd or any of the stuff that we have to do in other systems. And so that's kind of all you need to know, hopefully, for the rest of the talk about Kubernetes. All right, enter LinkerD. So LinkerD is a proxy. As I said, it's an RPC proxy. We want to think about it as a layer 5 proxy. It's built on Twitter's open source networking technology. So Finagle, Twitter is open sourced, and Netty has contributors from Apple and Twitter and all sorts of high traffic companies. And we wanted to make this very unopinionated about infrastructure. So it can sit on top of Kubernetes or etcd or Zookeeper and deal with all the service discovery madness that you have to do in all these systems. We use this. I mean, the real value of this, Twitter is a programming model. It gives us a way to write software asynchronously without worrying about too many of the operational concerns, like connection pulling, load balancing, retries. But this is really, as an operator, what I care about, is that every service that gets written, all of these things get taken care of. And they don't have to be different in every application. If I want to measure success rate, I know how to go ask the success rate question of a service that's not in a very service-specific way. If I want to change retry policies, I can do that in a predictable way. And so this becomes a real tool for SREs to be able to change these things. And so when I left Twitter, I said, whoa, you have to choose a library to do this today. And that means that in a polyglot world, if I have the JVM over here and Go over here and PHP over here, I have to solve these problems n times. And really, we should stratify this and pull this out into a proxy so that we can get all this operational value without coupling it to the language that you write your application in. So let's talk a little about layer 5, and hopefully a little bit about security. So again, here's this way of thinking about stratifying the layers of the stack. At the top, I have some user service request. Give me Alexor. Give me this user. That's not talking about building an HTTP request, hopefully, or building a thrift message, hopefully. It's like, I just want a user. The details of how that's done is kind of under the hood. So at a layer 5, we can think about that as a concrete HTTP request. I want I want this resource from the user service. Again, that's not the user service in this data center or that data center or staging or prod. I just want a user service. And then somewhere, we have to map that onto some real socket. And hopefully, that's encrypted. Right? And so we want some kind of concrete name. When we're introducing TLS, we're introducing connection security, not logical layer security. And so this kind of gives us this way to think about separating these things. I'll demo this a little bit. But specifically, we want this tied to service discovery. When I go look up something in service discovery, that's at the point where I want to secure it against. I want to say, I know this connection has been registered there. So yeah, logically, we talk about the abstract, I want a user. And this gets mapped kind of concretely into names. So this Finagle and the naming system LinkerD uses, we map every request into a name, some sort of path. And this gives us a way to identify requests. This isn't, we don't see anywhere in that talk to Kubernetes and go look that up. We need some way to bind this logical name to some concrete endpoint. Go look in DNS, go look in etcd, go look in Kubernetes, and if it's not there, go look on disk. All of those details shouldn't be bound in the application. This becomes specifically interesting when we want to think about deploying a new service, right? So I run the user service. 3 different services call me. I want to deploy a new version of it. How do I test that out? I can either just tear out the old user service and shove my new one in. That's probably going to piss off a manager sooner or later. Or I can have a whole copy of the stack, and I can have a staging DC, and nobody's going to want to maintain that thing. So I need a way to think about how do I use this logical delegation system to inject new services at runtime, new versions of services at runtime. And so we think about delegation. So a delegation, I might say, well, when you talk about the user service, the host users, actually map that into service discovery at this specific version. Or I may want to split traffic. I may want to say, send 90% of traffic to the production version of the service, and send just 10% of the traffic to my new version of the service, right? And so all of these concerns either going to be built into your application or have to be handled somewhere lower. And this is a nice mechanism for doing so. Furthermore, we can do this on a per request level. So here, if A is the timeline service and B is our user service, I can say, well, when you're like, here's twitter.com, whenever you're going to talk to the user service, actually use my new copy of the user service. You could also think about this being used to inject proxies, right? I can have debug proxies now that I inject at runtime that introduce timeouts or failures or all sorts of behavior, just as kind of a per request way of doing traffic grafting. Or you could even think about this kind of like dtrace, right? We're intercepting calls instead of library calls. We're intercepting network calls and changing how they behave. We've recently introduced a new component called NameRD. And NameRD lets us keep all this policy centralized somewhere so that I can just change routing policy globally by basically changing something in etcd or in Zookeeper. And then all the LinkerDs can pick this up and change their policies. And I'll demo this for you in a minute. This is kind of how it's deployed, right? We have some pluggable backends. All the LinkerDs watch NameRD for changes. So LinkerDs no longer have to talk directly to service discovery. They talk to NameRD. NameRD talks to service discovery and kind of fronts the view of the world. We can use this, again, securely by doing transparent TLS upgrading. So if you deploy this as a sidecar, for instance, in Kubernetes, your application doesn't have to know anything about how to establish TLS certs to any version of a service. In fact, I can have per service version certs. I can allocate certs when I deploy. And the application can be totally ignorant of that, and I still should get encrypted over the wire between hosts. We deploy, in the sidecar model, we basically wrap the service. So we take all ingress traffic, and on the outbound side, we look things up against service discovery. This lets us do we can terminate TLS here without the application knowing about it. Furthermore, we can do things like negative acknowledgements. Hey, I'm not going to deliver this request. Go try somewhere else. This becomes a very flexible way to install a networking stack for a dumb client. The configuration we use, this is LinkerD's real configuration. And I can say, well, when you're going to go look something up in Kubernetes, use the namespace and service to determine the common name. And so I don't have to have these kind of hard-coded things based around the logical names. It's not just about the user service. It's about users v2 in the prod namespace, for instance. And this becomes very flexible. I can do all sorts of per region certs. This is a nice kind of flexible way to inject cert policy. So again, at the top, the user service knows nothing about the cert it's using. Through the process of delegation, we bind that. All right, demo time. Hopefully this is a little familiar to you. Otherwise, the joke's going to be lost. I'm talking about magical security sprinkles. I'm going to talk about Job. And Job in Arrested Development writes the dumbest computer program ever. Really inane, really dumb stuff. And so we've turned that into a microservice. So it's scalable, can run this in multiple regions, and it's all going to be fault tolerant. And the way this works is we have a kind of very dumb web service that talks to two backends. The word service is basically a dictionary of dumb words. And the gen service is just going to repeat that word over and over and over again. And I want to deploy a new version of the gen service. And I want to do that gradually, without changing all production at once. And we're going to use NameService to do it. And we're going to do it securely. So again, we have each service is going to have a totally different cert. Even though the web just knows about the gen service, I can encrypt these to different certs. And this is all open source, this demo. So if you feel like going through this afterwards, if you know how to run Kubernetes, it should take you about 10 or 15 minutes to go through it. All right, let's tempt the gods. Is this big enough? Bigger? Oof. Well. All right. So here I've already done a deploy. I had to type my password in, so I created a CA earlier. And I did a deploy. So I wrote this deploy script. It just outputs Kubernetes configs. And you can see I have a common name of gen v0.default, and web v0.default, and word v0.default. And I have one version of the web service running, just so I can show you the cool dashboard. Otherwise, we don't aggregate stats right now. And I have 3 versions of the other thing. So let's look at the dashboard real quick. Oof. OK, better. OK, so we have traffic coming through here. And so I said we have 2 routers. We have an incoming side and an outgoing side. This is the web service. On the outgoing side, I see that all the traffic's basically the same. For 1 request to the web service, I have 1 request to each backend. We're doing about 60 requests, 100 requests a second right now. All of them are successful. And we have latency graphs. Again, totally platform agnostic. We just got all this stuff. All right. And so now the CEO comes running down. He's like, nope. Well, let's look at the service first. Yeah, OK. So I've turned off certificate checking because I have a self-signed cert. But we can see this thing just says some words over and over and over again in a microservice. Great. So now this works. The CEO comes down and says, hey, this is dumb. Nobody's going to pay us. We have to go fix this thing. So I've already deployed or pushed a new Docker image with the fix. And let me do a quick deploy. Gen growth hack. Let's just see what this does. Great. Oh. And so now we can see that I just wrote the script that spits out some Kubernetes configs. Here we have our certs. So we have a CA cert, and a public key, and a private key. And here's my replica controller. And here's my service. And so we create the service without a load balancer IP. So we don't let Kubernetes create the load balancer for us. We just create this as a headless service, so LinkerD can do its own load balancing. And we have the HTTPS port. And so now let's run that. All right, thinks we've deployed it. Let's take a look. All right, we're running 2 versions of the service. When I go, what's going to happen now? Anyone want to venture a guess? All right, nothing. It's all the same. I deploy the thing. It's not taking any traffic, right? Dark deploy. Woo! OK, now we want to just try this out. So this is what we might think of as staging, right? So I want to stage the gen service in production. And now I'll write a little override for our delegation system and say, well, when you would talk to the gen service, actually talk to the growth hack version. Am I spelling that right? Let's see. Great. Now we have loves Kubernetes and new lines in our version of the service. And it's great. And I go back to production. All right. Back to production. Production's still the same, right? So now I've done a staging deploy without changing any production traffic. And we're running any traffic there. Great. And so now I want to, we like this better, right? It's obviously better than what it was. So let's go deploy this. And so here's our little delegation that we're actually running in production right now. And I'm going to change this to say, well, let's do 90% to the new one. So for every 1 request to the new service, we'll send 9 requests to the old service. And I'll use my handy-dandy update command. And here, so we can see on the dashboard, there's new lines cropping up at the bottom there. And LinkerD, which is not configured with any of these service names, has just picked this up because we started routing things to a new service name. And so we have 6 requests to every, to 60 requests or whatever going through the new service. This is looking good. Latency is not, it's not great, but it's not that much worse. And success rate's 100. OK, let's go a little bit further with this. Let's go to 50%, sure. Now we see quickly this jumps up, right? Now not changing anything but this little config and named, and we're able to go at 50% traffic splitting. Excellent. That's what we want to see. So this is a nice way to do what's considered blue-green deploys in some environments. This is, again, canarying is another term for this. There's a bunch of terms for what we're doing here, but not a lot of good open source tools. And so finally, we're really happy with it. And this year, we roll with it. We're going to go. And we're going to keep the old service around for a little while in case something goes wrong. So I have a quick way to revert back. And we will update this immediately. All the traffic's on the new version of the service. And we can go down here and see. Yeah, no traffic going to the old version of the service. Perfect. Except a few minutes later, the CEO comes down. He's like, nope, people really don't love new lines. We got to go tear this out. And so we'll quickly delete the service. We'll just pull it out of the service discovery. And everything just falls back over. This fallback mechanism is really a powerful tool for things like multi-DC failover. So if this service is in the zone, fall back to the other zone, as well as a number of operability concerns. And so what we have here is kind of a flexible mechanism. By introducing a layer between your application and the connections that it makes and the load balancing that it does, we have a new place to start building tools. And so I want to argue is that while there are no magical security sprinkles, we need to start building more security tools at this layer. To that end, it's a fairly new open source project. It's built on tried and true tech, but LinkerD itself has only been open source, I think, since February or so. So there's still a number of things there. We're really think about LinkerD as a configuration layer over Finagle. And so we want to make a lot of Finagle's power exposed via a simple configuration as the goal. I'm really excited about gRPC. The demo that we just, or the talk we just saw was kind of a really good intro to that. Unfortunately, I don't support HTTP2 yet, so we have to do a little work with the Netty folks to get that in shape. That's in progress, though. There's a bunch of work going on there with people at Twitter and Google. We don't support client search yet, which for mutual authentication is really important. So we're going to be working on that. In general, we want a whole bunch more richer routing policies. So we can do this sort of routing policy here. But there's probably a lot more we can do that makes it easier to run services at scale. SLOs, I don't know if you've heard of these, but I want to be able to say things like, my 99% latency, my P99 latency should be 100 milliseconds. And if I start invalidating that, then I can fall over or go to other systems. We're this week going to introduce app-level circuit breaking. So if your app throws 500s, we can do automatic retries for you with a retry budget. And we'll be able to do things like fail fast. So if one instance of a service is throwing lots of 500s very quickly, we don't send it more traffic. We should send it a lot less traffic. And this is all stuff that's built in Finagle that we're exposing in config. Also, we want to kind of front service discovery entirely, so we're going to be adding announcers soon. That's in review. So I want to be able to register into etcd, for instance, with the application having to know about that stuff or have separate tools for that. And generally, we want to make everything more configurable. So thanks very much. Again, my name's Oliver. I'm on Twitter, and we have a Slack, and we have a beautiful website, which I didn't show you, but it's beautiful. And thanks for your time. Do I have time for questions? I don't know what time it is. OK. And I probably have plenty of time for questions if anyone has.
Yeah, so how does it scale?
How does it scale? Perfectly. So Finagle itself, the kind of underlying tech, does trillions of requests a day. Right? We trust the underlying tech very much, which is why we started there, and instead of writing our own language or our own framework in Rust or Go or something like that. NameService is newer in the system, but again, there are production instances of something very similar that are supporting billions of requests a day, probably. So I trust the tech. If there's certain scaling questions, I'm happy to answer them. I would probably say there are no scaling sprinkles, so this isn't going to be a silver bullet. But in terms of the features it gives you at a load balancing and kind of reliability layer, it's fairly well tested and production ready.
The question is mainly because you seem to be proxying every request.
Right. Yeah, so you should think about this kind of as like a outsourced client stack. So if you would do this in your application, in Python, for instance, this is going to be able to do better than your Python application, hands down. If you're doing super, super high throughput C things, maybe this will become a bottleneck. But our latency footprint in benchmarks is, I think, 3 nines is 4 milliseconds and 2 nines is under a millisecond. So this isn't adding a lot of overhead into the request path. Question in the back.
Where is the LinkerD running? Is it in the container, or is it like on the host?
Yeah, so LinkerD, we have a Docker image for it. It's up on Docker Hub. You can also just download a binary and run it. And so in Kubernetes, we deploy this as a sidecar. So I can show you the config if you want. But there's actually, let me go back to that. Here we see in our Kubernetes config, we have 2 containers in that pod. We have the service itself here, and then I have a LinkerD pod down here. And the configuration gets mounted as a config map. Does that answer the question?
So all this transaction is happening in the user space?
Yeah, all this is happening in the user space. Again, I would think about this as much as like what's in your application already. You're going to have some probably poor round-robin implementation or connection pooling thing. You can make your clients dumber in your application and use this to do smarter user-level routing. All right, if that's it, thank you very much. Thanks for having me. Check out LinkerD.